graph with n vertices numbered from 0 to n minus 1 in an array edges where edges I equals from I and to I represents a directed edge from node from I to node to I. Okay. 0, 1. So this is from 0 to 1. 0, 2. So from 0 to 2. 2, 5. So from 2 to 5. 3, 4. So from 3 to 4. 4, 2. So from 4 to 2. Okay. Find the smallest set of vertices from which all nodes in the graph are reachable. It's guaranteed that a unique solution exists. Notice that you can return the vertices in any order. Okay, so we actually have to push. So in this case, it would be 0 and 3. All right. Okay. So from 0, we can reach 1, 2, and 5, but we can't reach 3 or 4, so we'd actually have to. Okay. Okay. That makes sense. It's not possible to reach all of the nodes from a single vertex. From 0, we could reach 0, 1, 2, and 5. From 3, we could reach 3, 4, 2, 5. So we output 3 and 0. And then in this one, same thing. We go from 0 to 1 to 4. But that doesn't include 2 or 3. So we still have to go from 3 to 1 and then 2. Okay. So it's basically like asking for all the starting points, essentially. All the possible starting points. So the constraints are the number of nodes is going to be anywhere from 2 to 100,000. Edges.length. So the number of edges is going to be at least 1. One to 100,000 or 100,000 divided by 2, whatever's lower. Edges I dot length equals 2, so that means each one of the arrays inside of the
always
main
a pair.
array. Yep, it's always going to be 2. From I and to I are going to be anywhere from 0 to n. So from I and to I are always going to represent one of these nodes. And then all pairs from I and to I are distinct. So it'll never be like 0, 0, 0 going to itself. Okay.
Huh, so there's no more than, what's that, 100,000? Wait, no. Yeah, 100,000 edges.
100,000 nodes, and then
100,000 edges as well.
100,000 edges too, yeah.
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 Okay.
Interesting. All right.
Okay, yeah, the browser version of VS Code is very buggy.
And then, hold on. Nodes is going to be 2. There's going to be always at least 2 nodes. And then the nodes, are the nodes going to be 0 to n?
Yes.
Yes, okay. Okay.
Yeah,
Cool.
so the n is not like it's not like the size of the edges list. It's the number of nodes.
No, it's the
instead.
number
Like
of
the
the
edges list
actual
be,
nodes. Yeah.
yeah. Most likely the edges list will be longer than n.
Okay, so we have to find all the nodes that no other node points to, basically, right?
Yeah, pretty much. You're just finding the root nodes.
Yeah. So these are the nodes that are being pointed to. And these are the nodes that are doing the pointing.
Mm-hmm.
So
Yeah.
the nodes that are being pointed to.
I
Wait a
mean,
second. If that's it, can we just take the first item in each subarray of edges?
well, you want to find a minimum set. Like you can't just take the first and then like do it. You have to make like because a lot of those that are listed there, like 2, can be reached to from another node. Also, it is definitely non-trivial to go from like a non-trivial math proof to go from the problem description to saying that it's all the root nodes, but it totally is. Like you just gotta
Yeah,
find the
I
root
feel you.
nodes,
I
yeah.
feel you.
Yeah. Gotcha.
Yeah.
So yeah, so if we're focusing on this first one right here, the 0 index in each one of these arrays is gonna include nodes that are not root nodes.
Oh no, well you can have a root node in the first index, and like look at 0 shows up.
Yeah, you can. That's what I'm saying. It includes nodes that aren't root nodes too, though. Like two's not. Well,
Yeah.
yeah, 2 is a root node, but
No, 2 is not a root node. Oh,
in
in this
this
one it
one,
is. Never mind. Yeah,
yeah,
in that
Yeah,
one.
directed it is.
but
I was
one,
thinking of the first example.
yeah, one's not a root node though.
Nope.
So the 0 index in each one of these arrays, it'll include root nodes, but you guys hear that?
Hmm?
I live next
I
to a
heard something.
highway, and it's just
Ooh.
sometimes like motorcycles and cars racing at night. It's so annoying. Okay, yeah, because the 0 index is going to include nodes that aren't root nodes, but then the second index is going to include the second index doesn't include any root nodes.
Well, the second
So is it
index is always being pointed to. So if something shows up in there, it can't be a root node.
So it's all the first indexes that do not appear as a second index. So if a node, the value appears only as a first index, then it is a root node.
Oh, you don't
Yep.
even need that. Actually, you can. You don't even need to care about the first index because technically, it is possible that you could have a node that just doesn't point to anything. So it's any
Oh,
number between 0 to n that doesn't show up as a second index.
Oh, you were saying if it's in the first one, but it's not in the
Mhm.
second one, then yeah, you're right. Because if it's not in this one, then it's a root node, right?
Well, that part, yes, but you don't actually need to look at the first index either.
At all.
In fact, you shouldn't because it's possible that you can get you can have a vertex that doesn't point to anything, and that should be included in your list.
But
No, that's not possible.
they say it's all pairs of vertexes. So
Yeah,
Uh-huh.
they're gonna be pairs and they're distinct nodes.
No, all the pairs are distinct. No, they don't say anything about having a node that doesn't connect to anything.
but you mean
Yeah,
a node that connects to null? You're saying that there's
No,
going to be a node that connects to null?
Not that a node connects to null, but that a node has no edges coming out of it.
no, that's not possible because
no, they're
It is.
each
And
one
it's
of
not in
these
the graph.
is a pair, and each one of these is going to contain 2 nodes that are distinct.
Oh no, that's not what I'm talking about. So okay, so you've got the vertices, right?
Yeah,
You like n tells you how many vertices there are.
yeah,
There's 0, 1, 2, 3, 4. There's 0, 1, 2, 3, and 4 in this example, right? But then I'm not talking about edges. I'm talking about vertices. So
yeah.
like imagine that you have say n is equal to 5, and then your edges list is like 0 to 1, 1 to 2, and then nothing else. Then in that situation, then the vertex like 3, 4, and 5 wouldn't be connected to anything. They would just kind of exist. It'd be like a graph, and then there's like a couple dots that don't have any arrows coming in or out of it.
well, they're not going to give us that because they want us to find the minimum number of vertices that can connect to everything.
Right. Well, that still fits within the problem. You just have to include every single non-connected vertex.
Well, I'm not a math expert, but I think their constraints are telling us that there are no orphan
Standalone nodes.
vertices. Yeah, everything connects to something.
Yeah, it's unclear. They don't say explicitly either
Well,
or.
There is a
What
term
does
for
the
this. It's
length
called
of
a
edges
connected
I
graph.
is 2?
It's called a connected graph.
Yes.
But they don't say it's connected. They only say that it's directed and acyclic.
True. Yeah, you're
Mhm.
right. You're right about that. And they would specify it was a connected graph if it
Mhm.
was, you're saying?
Oh yeah, 100%.
Okay. Gotcha. So we don't
Yeah.
care about, so can't we just take the number of nodes that there are and
Map.
subtract these ones that have a node pointing to them? Because, all right, hold on. So we
Yep.
got
Pretty much.
1, 4, and 4 in this case, right?
Hmm.
And yeah, 1, 4, and 4. Yeah, 1 and 4 are being pointed to,
Hmm.
and the other three are in the output. So all we
Yep.
need to do is um like kind of understand all the nodes that exist, and then eliminate these nodes that are being pointed to from that.
Yeah, that's basically what I did.
That's what you did. Okay.
Yeah.
There's probably a few different ways to do it.
I probably will have a different implementation than you, but yeah, that's pretty much it.
I'm thinking set. What makes you say hash map, Kev?
Oh, never mind. Y'all are being sneaky.
Well,
Why?
I mean, you can use a hash map, but you can actually go a little bit faster than that. You can use an array because it's all numbers, so you could just have an array of size n that's an array of booleans, and then like basically loop through the list of edges and then flip the boolean if it's like if it's the second number in the edge. Or you can just use a set. Set works too.
So create an array. I mean, at the end, we'd still have to return it as an array anyway, so we'd have to convert it.
I mean, honestly, a set would be you just do it in like one fell swoop, basically.
Well, with a set, you can
Uh,
just, if we encounter one, we could just,
yeah, you could remove it.
Delete it.
we could delete
Hmm.
that, right?
Yeah, the array method is probably way faster, but the set like makes sense too.
Yeah, we could do that. Because then,
Hmm.
all right, you said create a new array filled with zeros, and then we're
Well,
not going to be
I said
delete
like false, but I mean, I suppose zero is false basically.
false. Yeah, just as a flag,
Yeah,
and then if we encounter a number, then we flip it to true, and then
yeah.
we basically push the index of anything that has false, essentially,
Hmm.
right?
Yep.
Okay.
And that is exactly that's like literally exactly what I did.
Okay.
Yeah. I think the array is probably faster than a set, but I mean it's JavaScript, so everything is really high level, and the interpreter is a mess. So I couldn't tell you what would be faster in there.
So then we try loop.
Well, and it can actually behave differently based on the inputs.
Yeah, yeah. Change based on your browser too and everything.
Switch edges I 1 to true. No, we actually need, it's not edges I, it's array I, right? Switch
Right.
array to
Because
true.
we want vertices in our answers.
And then okay. I think that looks right.
Last step, Bob's your uncle.
A
This one doesn't really seem like a medium.
Hmm?
Feels more like an easy. especially for a graph problem.
I think the main difficulty here is more realizing that you have to worry about the root nodes.
Okay. Yeah.
It's interpreting the problem and then figuring out like mathematically what they're asking for is the root nodes. I don't know, maybe not.
Yeah.
I would call it non-trivial.
Yeah, certainly not true. I mean, I suppose also like finding the root nodes can be a little bit tricky if you're not familiar with graphs or anything. I know that one of my first guesses
True.
was to try to like traverse the graph for some reason to try to find the root nodes until I realized that you could just check whichever ones don't have a connection.
Yeah.
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 I think I'm
I
used to
was stuck
graphs
on
being
like
done using
traversing.
references. Yeah.
Yeah.
I was just about to like make like a while loop with a for loop in it or something and like keep track of which nodes are still contained and like backtrack through and everything, and then I realized
Yeah.
you could, since the edges are listed out in array format, you can just do that. I think I was probably I'm probably too used to working with graphs when everything's done through references, like references or pointers.
Yeah.
And that you probably like have to like traverse backwards and stuff.
There's so many different variables when it comes to graph
Yeah.
problems. They're really just
Mhm.
the directed acyclic alone,
Mhm.
then the connected. It's like,
Mhm.
yeah, there's so many
Yeah,
different.
graphs get icky.
All right. Does someone want to try to fill this out? Virginia, you can hop in and try to fill this out too if you want, just to get your hands dirty and type along.
Okay.
Yeah, it can't hurt.
Yeah,
You could try it and see.
right now it seems like it's more an array problem
It
than it
does,
is.
right? Yeah, the array
Yeah.
problem we had yesterday was at least 2 or 3 times as hard as this one for sure.
I wish I could. I wish I could go to that, but I had my work schedule was really weird, so I couldn't make it. Unfortunately.
Yeah, it's all good.
Yeah.
Yeah, this is a fun one.
One of these days, VS Code will finish installing on my computer.
It's just been like installing for weeks.
Well, it like hit a bug, I think.
Uh,
Yeah. Oh, why is it doing that? That's annoying. Okay. Well.
yeah, I was looking at some graph algorithms this morning, some shortest path algorithms like Dijkstra's algorithm and a couple other ones this morning while I was at the gym, and it's like, man, even just for one type of problem, like the shortest path problem, there's different variations of the shortest path problem, and there's different algorithms that are best for that problem depending on
Right.
like how many nodes
Optimized
there
for
are,
different things. Yeah, optimized for different reasons.
how many
Oh.
depending. Yeah, if there's more than 100 nodes, then you want to use one of the less efficient algorithms because they can handle negative weighted edges, and oh my goodness, it was like,
Oh. Oh yeah. Well, I mean, there's algorithms that'll be faster for smaller inputs, and algorithms that are slower initially but are way faster for larger inputs.
yes.
And then there's like sometimes you'll get graphs that are like based on like Euclidean space, like a graph between like cities or whatever with distances, and then you'll have graphs that can't be embedded, and then like negative weights and all that random crap. It's fun.
Yeah.
Graphs get very complicated. I mean, you know that the Floor color theorem was only proven because they basically like reduced they reduced down the problem to like a few hundred like basic graphs, and then they just had a computer go through and check it. And there's big controversy in the math community.
I saw a fascinating video. It's been about a year, but this guy who works with tremendously large graph problems was saying that they started noticing when you get. He mentioned some specifics about the type of graph they were studying, and it's been too long. I can't rattle them off. But for this class of graph problems he's looking at, they started noticing once they reached a certain size and level of complexity, they started taking on similar meta properties, like very similar meta properties. So it's like they stumbled on something very fundamental mathematically that I couldn't grasp, but
Ooh.
it was fascinating hearing him talk about it.
Yeah. I mean, graph theory has a lot of like unproven stuff about it. I mean, just look at like there's a lot of NP complete problems that are based on graphs, like the traveling salesman problem, Hamiltonian cycles, stuff like that. And so like
Right.
we're technically we don't. I mean, the only known algorithms to solve those problems are exponential time. So like
Yeah.
yeah,
With
um,
classical computation, you run afoul of
Mhm.
falling into local minima
Oh yeah. And we
or
don't know if
maxima.
there's anything faster or not. And
Well,
quantum computers
hypothetically, a
can't do it.
quantum computer could do it.
No. Quantum computers still can't. It's still not known if they can or not.
Well,
Uh,
hypothetically.
uh, maybe I don't know. I mean, that's an open problem. There are a couple problems that a quantum computer can do in faster runtime, but technically, it's not the entire class of NP problems. Oh goodness! Now I'm starting to sound like a nerd. I'm sorry. Oh goodness.
Nah, I've been digging into math like when I'm falling asleep from like 10 to
Uh-huh.
10:30. I watch like some Khan Academy videos and YouTube
Yeah.
videos. I'm trying to brush up on my math because I feel like that's the one thing limiting me in the whole computer
Mhm.
programming world. So I'm like trying to brush up on it,
Right.
but I feel like a nerd. I'm like, man, I should be watching Netflix right now or like one of these shows that everybody's talking about, but I'm
No,
sitting here
dude,
watching
dude,
math videos.
dude, you just gotta embrace it. You just gotta embrace it.
I
I
know.
literally tutor. I tutor people in math, and then like I get done with my shift, and then I pull up YouTube. I'm like, ooh, what should I watch today? And then I'll end up watching like a dude just like solve an integral. Like, I'm like, how did I end up like this?
Seriously, I know.
I'm done. Like, I'm like, wait, this isn't even like a pop math thing. This is just like this dude's like, yo, this integral looks interesting. Let's do it. I'm like, why?
Yeah, yeah.
Oh man, yeah, but there's some cool stuff in the higher
Yeah,
level maths and
I
everything.
was
Yeah, there
struggling
is.
my way through Cal 2, and then I read in the paper that they had a Fortran program that could integrate 98.9% of the problems they threw at it. And I was like, why am I
Wow.
studying this?
Yeah.
Oh, I mean that sounds very interesting because
And
integrals are
that was
obnoxious.
1985.
Hmm. Yeah, I mean being able to solve integrals analytically is like a whole big thing. The algorithms are super complicated for that. Now, of course, to approximate it like numerically, it's easy, but to do it like with to actually like find an analytics like an actual closed form solution can be very difficult because there are some that just don't have a solution. And there's like 50 million different techniques you can do, and not all of them work all the time. It's just a big mess. So I'm honestly just impressed. Uh, yeah. Anyway, uh,
I feel like
I
there's a
think
lot of
Virginia
potential in
kind
math.
of.
Yeah, no,
Oh
I
yeah.
was watching that. Let's see. Okay, so array edges dot length. Actually, I think it's gonna be array n because edges dot length because we have 6 nodes, but
Hmm.
edges dot length might not necessarily reflect the number of nodes, right?
Oh, it definitely needs to be. It definitely needs to be in.
Right.
Ooh, okay.
Oops. Yeah.
And then
Yeah.
filling it
Yeah.
with false. Okay.
Yeah.
No,
This isn't C++ where like an array is passed with 2 arguments.
And then result. So
Wait,
loop
you
through
you
the
don't need
edges.
the semicolon?
The semicolon.
Yeah, you don't
Oh,
need a semicolon in JavaScript.
it's
you
been
don't
optional for
you
a long
don't
time.
need it. Yeah.
That's weird.
I think it's still a best practice though.
Yeah, it's in so many other languages that
Because
it doesn't hurt to use
there are some cases where it'll keep interpreting. Like if you start the next line with like a parentheses, then this line might
Mm,
continue interpreting the next line. So you're better off just
yeah.
using them or
Right,
a
right.
protective one.
Hmm.
But yeah. Okay, so loop through edges. So let edge of edges. And then for array, edge 1 is going to be this one, then this one, then this one. So you're passing in 1.
Hmm.
So array 1. you're setting from false to true. 2,
Yeah,
you're
this is
setting.
a very crude example of fuzzy math.
Yeah, I like this.
Fuzzy math?
It's very crude, but yeah,
Wait, where is it fuzzy math?
because you're as you loop over the same array element might get it doesn't get flipped, but I mean it meets the criteria multiple times.
Oh. Oh, yeah.
Yeah, it's
Right.
Oh, you're saying you could
it's only 0.1% fuzzy math, but you can see it in there.
Yeah, you might end up setting a spot in an array to true multiple times, but that's fine.
Gotcha.
Yeah.
That's right.
Yeah, that
Let's
makes
see.
sense. Okay. And then we
Yeah.
are looping through this array, which has just had some of its indexes flagged to true, and if array I, which if it equals true, just push that I onto the results array, and yeah, I think
Oh, you want it to be not array. You want to invert it, because although you set the ones to true, to like the ones
yes.
that
All right. All right.
yeah.
Yeah, you're right. All right, let's try this out. 0, 3, 0, 2, 3. Nice. Woo-hoo. See if it
Submit.
Let's see.
runs.
Submit.
Nice.
Oh hey,
Nice.
it's 89%. It's faster than 89% of submissions.
Yeah, that's
Uses
awesome.
92% more memory than 92, less memory than 92%.
Like.
Nice.
Hey, I told you this was the faster way than a set. I'm actually curious. Maybe we could write it with sets instead and see like what like how it compares in terms of speed. I don't know. Maybe not.
Yeah.
My gut says it has to be slower, but
Oh yeah, for sure. Well, I mean, it's done
So-
using a hash map behind the scenes, so you have to convert the hash. You have to like compute the hashes every time. No idea.
Let's try
Oh
it.
right, my Visual Studio Code.
How do you fill a set? I've actually
I don't know.
about to find out.
Is a set used? Oh no, you don't need to fill it. So okay, it's a completely different algorithm.
You need to have from 0 to n, right?
Right.
And then start.
How do I? I'm sorry. How do? Oh right, yeah, you do need to fill it. Sorry, I'm a dumb. You're right. You'd have to have a for loop where you like you add to the set.
Oh, really? There's
Yeah,
there's got to be a way where you could just fill it with like 0 or false, though, right?
Like 0 through n.
Yeah.
You just, I mean, I don't know, why not just use
Yeah, because I know add will work.
yeah, you might just have to do a for loop. Let me see here. Do you need like a plugin to do the collaborative workspace?
yeah, it's called Live Share. 2 words.
Oh, okay.
Yeah.
Okay. Cool.
Yeah, they call them extensions.
Ah,
We could try.
that actually helps. Okay.
And it's kind of smart. If VS Code notices you're using a given language, it'll suggest certain extensions to make it easier.
It's not Git live, no.
No, it's just called Live Space Share.
Okay. Don't worry about it. I'll
It'll be the first in the list. It's from Microsoft, and it should be pushing about 9 million downloads at this point.
Ah.
Oh my god. Well, I have solved this.
Oh, you did?
My solution is faster than 5.34% of JavaScript solutions. It is the slowest thing possible.
Hey, that's fine.
My
And
first
sometimes the
attempt
slower
definitely
solution,
timed out.
sometimes the slower solutions can give you like insights into the problem, though.
It was just the messed up brute force way. I'm like, okay, well, if you're in position 1, but you don't appear in position 2, so let's make 2 arrays and filter them and turn them into a set and mash it together. But
Does someone
my
want to
first
drop?
ever graph.
Does someone want to drop down to the Python and see if they're done, and then we'll share all of our solutions?
I'll go look into Python for sure. I think I remembered how you directed. I think I can find my way. Let me go check.
I also have the Rust solution as well, if you want to see it.
Yeah. I'm just gonna try to implement this in with a set really quickly.
Add. It would be node flags dot remove, right? Is it remove?
It's either remove or delete. I can't remember.
Yeah, it's delete.
It's always different. It's a big pain.
Yeah,
Like for
there's always
lists,
synonyms.
yeah, in Java, like it's not push, it's add.
Right.
Yeah, we use put sometimes, or puts, or I don't know. Yeah, but node flags that delete.
Okay.
Can you just like return a set? I wonder.
Yeah. Well, yeah, because we already have the set here, so we could skip that for loop entirely, right?
Okay. Yeah, you might just be able to.
Let's try.
Uh-huh.
Let me just comment this out very quickly. All right. Let's see. No.
Okay. Huh?
No. It's returning
You just need
an
to.
object.
No, that's
Yeah,
right.
you just need to turn it into an array.
Oh yeah, well that's gonna be kind of costly, isn't it?
This might.
Yeah.
Yeah, there we go.
Oh yeah, this is definitely gonna be slower because it has to convert it from a set.
Let's test them out.
I am still curious, like how much slower though.
Yeah.
Wait, did you? No, did you? Oh yeah, you did. Yeah, 60 did. Huh.
Well, there it is.
Uh-huh.
I wonder. Yeah, I wonder if we were able to. Yeah, I guess you're right. We do have to loop because we have to increment with each one, and there's no. Yeah. Yeah. Well, on the second submit, it was 92.91.
Mm-hmm. Oh yeah. Oh, arrays are gonna like beat out basically anything every day.
True. True. Yeah.
Yeah. Arrays are fast.
True. True.
Because
The
they've
only
been
the only thing
heavily
is
optimized.
we were able to cut out an entire for loop though. Which
Well, arrays are just inherently a pretty wait. Yeah, arrays are just pretty inherently fast because like
Yeah, they make
RAM is random access.
Yeah, they make a nice predictable pattern in memory and everything.
Mm-hmm.
And down there,
Dude,
they may be close, maybe not. I'm not sure they know. I'm not sure how familiar they are with the syntax of what they're trying to write.
I'm gonna pop down there real quick and see what's going on.
Should
I'll
we
be
just
right back.
I mean, I'm sure someone just joined. Maybe they
How's
have a better understanding.
Hey, Jimmy, this is perfect because I just found out that my solution is actually not a solution, which makes me very upset because it would run in O of n time if it were.
What did you are you sharing your screen? Let me see.
No, but I will. Give me a second here.
Let me stop sharing real quick.
You don't have to actually. That's the funny thing about Discord. You can see my screen now, right?
Yeah.
Yeah. So this is the problem here, line 7. I initialize it at 0 and I start at 1. And then I basically say if the vertex is equal to the previous vertex or the previous next is equal to the vertex, then continue. And then I put it in my map, and then I basically say if it doesn't exist in the map, then go ahead and push it onto the array. But the problem is that apparently not every of these graphs start at 0, even though it says that every single one of them starts at 0 right at the fucking top of the problem.
Yeah, I was gonna ask that. How do you know that 0 is gonna be on one of the root nodes?
Literally says it like right here at the top.
Vertices numbered from 0 to n-1 in the array edges represents a directed edge from... Yeah. Yeah, it says the vertices are numbered from 0 to n-1, but not that 0 would be a root node.
I guess so.
Because if something points to 0, then it automatically wouldn't make the return.
And I guess what I could do is I could just take this out, right?
Yeah.
God, I hate it.
And then
I
map. Well,
hate.
I is less than edges dot length. Let
Right.
vertex next. Okay. Vertex
Right. I hate
next.
having to push to talk, but I can't take it off because I have a horrible echo on Discord if I do.
What do you mean?
I can't take my push to talk off.
I didn't even know you were doing push to talk, honestly.
Yeah, that's why you keep seeing the tilde sign on my thing, is because I have to hold the tilde down to talk.
Oh, gotcha. Okay. Alright, so we got vertex next. Edges I, let pre-vertex previous next. I don't even know if you need that line 11 right there. I think you would be good with line 10. Because you're going to be... Yeah, because you're going to be starting I at 0, and then if vertex equals previous vertex... Yeah, you wouldn't need any of that stuff. You would just need to... So you need 2 for loop. Well, let me see the way you're doing.
No, you don't actually need 2 for loops. That's the funny thing. That's why I have the map. So you say, but if I do it this way, I have to set a condition. I'm gonna have to do this.
So what is the if vertex equals previous vertex?
Yeah.
Or
Right.
previous vertex equals vertex. Continue. So you're checking the 0 index in each internal array. Yeah, I don't really know exactly what you're trying to do here. You want to come back up to the other channel and we'll share our solutions, and we could try to, because if we could get everybody's heads on it, then maybe we could bust out this solution with you too.
Yeah, I could do that.
See you in a minute.
Brain, but maximum there's like that many squared.
All right, they're popping back up.
Awesome.
Yeah, you have like 100 billion neurons, so.
Oh goodness. So that squared is the maximum.
Well, it's more
probably not that
complicated.
many, though.
Some neurons connect to like hundreds of others. Other neurons only connect to 2 or 3. So it's not.
Yeah.
You can't.
I'm putting an upper bound. Okay.
Yeah.
I was just reading this book the other day. You guys are talking about neurons, about how it was called The Brain, The Story of You by David Eagleman, I think his name was. And he was saying how when you're born, you have the same number of synapses as an adult. But from 0 to 2, the amount of synapses you have just explodes to a level that's just you can't even imagine it. But from the age of 2, like
Yeah, your brain can't assume its final form, or your head would be too big to go through the birth canal. That's really freaky to think about.
Mm-hmm.
I don't know what you
And
mean by final form, bro.
newborns' brains aren't fused together. If you ever seen an X-ray, there's gaps between the plates in their skull,
Yeah.
and as they grow through that period you're talking about, the brain actually increases size physically and expands, and their skull has to kind of knit around it.
Yeah, what this dude was saying was that like every what is it called when you say like a certain like what are the things that Japanese letters have and Russian letters have that maybe like we don't have those sounds in English?
Uh,
What
phonemes, I
sounds?
think they're called.
Phonemes?
Yeah, something like that.
Phonology?
Yeah, like all
Japanese actually, there's not really very many, but
Yeah,
Chinese maybe.
there's lots of languages that have unique phonemes.
yeah,
And to other ears, they sound they can say two things and they sound exactly the same to like an English speaker,
Mhm.
but to a speaker of Inuit or whatever, they can tell the difference easily.
Mhm.
It's really
Yeah.
weird.
yeah,
Yeah,
he
in
was
Chinese they actually have tones, so like the pitch change in
yeah,
a word
yeah, yeah.
actually does meaning.
So he was saying that all of those exist within every baby's brain. Every baby at the age of 2, they have the ability to speak all of those. But as they're only around English speakers or Chinese speakers, it's not that they're learning how to do things and that they're adding more synapses. It's that the brain is actually pruning and cutting synapses that they're not using. So it's
Yes,
like all the
yes,
possibility is there right there, and instead of like building new pathways, it's really pruning it's really pruning pathways that aren't being used. So it's like imagine if they were just using like as many pathways from 2 until like that's almost what parenting is, like help your child use as many pathways as possible so that it's pruning the least amount, but at the same time you want to get good at something too, you know.
right.
But I thought it was interesting you guys were talking about that, so I thought I'd share.
Yeah, there's another interesting project going on. Any given human gene, uh, people have millions of mutations in their genes. But if you study a large group of people, you can figure out what is an unmutated version of a given gene. And they're starting to map together what an unmutated human genome would look like, because there's none in reality.
Wow,
Hmm.
that's
Well,
interesting.
no, of course not. This is how it all works, right?
They found out just a few years ago, they were able to prove, now that we have genetic sequencing, that babies will experience spontaneous mutations in certain genes, and it's random. No, there's no pattern to it, but random spontaneous mutations in the womb. And this was unguessed at, but they found it by DNA sequencing.
Yeah, that stuff is super interesting.
So what tipped them off is there were kids that had certain types of genetic diseases. You have to get it from both parents in order to have the actual disease. And kids were showing up where only one parent had the trait, but the kid has the disease, and they're like, "What's going on here?" And it turns out, just maybe it's cosmic rays. They don't know why this happens, but something randomly mutated the extra gene and gave them the disease, even though they shouldn't have got it because not both parents had it. And
Yeah,
this is all very rare. This is 1 in 100,000 or 1 in a million type people.
gotcha. All right, let's share some solutions.
Yeah.
It's 8:15. We're running a little over right now. So,
As usual.
I don't mind.
Lee and the last Uriosti over there, they were working on a solution that only had one for loop. So I don't know if you guys want to share that and just they didn't get it working yet, but I'm interested in the solution and I figured maybe we could help them work through it because it looked pretty cool. You're using a hash map. I don't know which one of you guys want to share your screen, but
Oh, I got it. I got it up.
cool.
I don't know why I'm running into a runtime error right now. I think I have it. So originally what I had done is I had started at 1. Oh, I know it's wrong.
minus 1.
Yeah, so originally I started at 1 and just, there we go, perfect. Now it's an O of n solution. So what I do is I create an array, which is the final array, that's the heads, and then I create a map, and I iterate through until the second to last index. And I mean, if anyone's unfamiliar with array deconstruction, basically I say that the current vertex is equal to I plus 1, and the previous vertex is equal to I, right? And this edge case right here, this if I equals 0, this is because the first value that is in your array is always a brand new output. It's always the head of a graph, right? So you always have to push it into the head, and that's why you have to set this condition right here, this edge case. And then this condition just says if the vertex is equal to the previous vertex, or the previous next is equal to the vertex, continue. So basically the way that works is it says, does 0 equal 0? Yes, so continue, right? Now we go to 2, 5. Does 2 equal 0? No. Does 5 equal, does 2 equal 2? Yes, it does, so continue. Then we go to 3, 4, and we say, does 3 equal 2? No, 3 does not equal 2. Does 3 equal 5? No, 3 does not equal 5. Is 3 in our map? No, it's not in our map. So we're going to add it to our map, and then we're going to push it to our vertex head, or to our array. And this runs in O of n.
Hmm.
How come the first one is a 2 and not a 0?
Uh-oh, that's not good.
Bugs.
Why is the first a 2 and not a 0? Oh.
Because it's I plus 1. So you want to do previous for yeah.
Wait, are you not visiting the last edge?
Yes, I do visit the last one because
there's an I plus 1.
Yeah, because the logic I always use now is vertex. I know that's a little confusing. Originally I had started at 1 and I was going to the length, but then I realized it wasn't, and I had initialized this to 0. But then I realized that not every graph starts at 0. So so I had to refactor the code a little bit. Yeah, so that's why the nomenclature is a little weird. If I like really wanted to rework this, I would call this next vertex, next, current vertex, current next. But the names still line up because this is really the one that you're looking at through every iteration of the loop is line 10. You're really just looking at this one. This previous is really just a comparator. So this is actually really similar to a problem I saw on that they gave someone like who's the guy who invented AlgoSmart. He was giving it to someone that was like really smart, and he's like, if I'm a farmer and I'm going down a row of carrots and I want to check each carrot for a rabbit, and every time I check the hole, the rabbit jumps to another hole that's either one to the right or one to the left, right? And basically the way you do it is by starting at the second index and always checking the one behind you, right? So that's kind of what I do here is I really start at this one and I say, and then my logic says, does the vertex, which is 0, right? Does that equal the previous vertex, which is 0? It does. So then I just continue to the next iteration of the loop, right? And then I go to here, and then I say, here's the current vertex now. Does 2 equal 0? No. But does 2, which is the current vertex, equal the previous next, it does. That means that the graph is connected, right? So if you look at it, it's like 0, 1, 0, 2, right? So if either the next value of the previous array or the current value of the previous array, if either of those values is equal to the current vertex value, that means that the graph is connected.
Yeah.
So, would this still work if you rearrange the order the edges were given to you?
That's a good question. Yes, it would. Yes, it would, because it always just tests the thing that it always tests is this, right? It's always testing the vertex, and it just says does zero equal the previous. I mean, they have to stay like this, because otherwise the edges, you know what I mean? Like it always has to go like this. This is how the array is read. It can't really be written any other way.
Well, you can rearrange the order that the edges are given to you. It will still be the same graph.
Yeah, it would just be unsorted.
Yeah, it would just be unsorted.
What is the time and space complexity when you click submit?
Well, the time complexity is O of n. The space would be
I think he just means how fast is it compared to everybody else.
I mean,
that is what the time complexity is, though. Yeah.
And I'm wrong. What the heck? Well, I guess I'm wrong.
This is unsorted right here.
Yeah, I think so. If I understand correctly, I think you're trying to traverse the graph, right? You're trying to traverse the graph to find nodes that aren't connected to anything else, right?
Right.
Well, the method that you're using isn't going to properly traverse the graph, because you could come across a vertex where the edge that it's connected, that connects it to something else, is located somewhere else in the array. Or you might come across the current vertex that you're looking at, and then you need to loop over the array again to find the edges connected to it.
So is there a way that I can store that information and still keep the probably not?
Oh, of course there is. With a complex enough data structure, again. Yeah, in order to do a graph traversal using something like this, it's got to be a little bit more complicated. Where it's in. I don't know for an acyclic. Acyclic is probably simpler, but in general, a graph traversal requires you to mark what nodes you visited and stuff like that.
Well, that's kind of what I'm doing with the map, right?
Right.
That was what I was doing with the map.
I think you just have to loop over more stuff.
Yeah.
To catch everything. I think. I don't know.
I don't know.
Mm-hmm.
It was an interesting idea. I kind of hate that the examples are so poor compared to what the solution demands.
You could post it to the server and just ask someone if they know how to tie this solution up without adding any more for loops, because that's what you're trying to do, right?
Yeah, that's essentially what I would like to do, but
I honestly don't think it's possible using this approach.
I could sort the array, I guess.
I feel like that wouldn't help. Maybe.
True. I wonder if you sorted it by the first index.
Yeah, if you're trying to make it be O of n, when you start getting into those algorithms, it gets harder to analyze it.
No, but if I sorted it, it would still be O of n log n, which isn't bad.
Because right. No. But you still you'd have to backtrack, I think. It's not exactly obvious how you would sort it, I think is what I'm trying to say. I think it would still be O of n squared at that point, because theoretically you might have to backtrack through the array n times until you find the find an edge that connects to the node you're looking at. I have no idea.
Let's see.
Yes.
Yeah.
This solution O n square?
Hmm?
This solution is O n square?
Well,
and
this current algorithm is O of n, but it's not
Okay.
a complete. It's not a valid solution.
I get an ON solution and it passes the
you
test.
got to put equals with the arrow right after the parentheses in the sort function.
Uh,
Yeah, there you go.
There is definitely there's
I
definitely
have
an
O-
O of n solution, 100%.
Yeah, I have ON solution.
Mhm.
Mm,
Yeah, we in the JavaScript lobby we found an O of n solution as well.
oh, okay.
Hmm.
Yeah, we can share our solution really quickly.
I have my
Yeah,
Rust
go for
one if you want to see it.
Yeah,
I'm
yeah,
curious.
I'd like to see it in Rust.
Okay.
Omar, you got a snippet tool, Omar?
Yeah.
Like because when you post it, just like copy and paste in the text, it's a little hard to
Uh,
read. But when you use the snippet tool, it's a lot easier.
Okay,
Just
can you see it?
just a heads up.
Can you see the code and everything?
Let's see. Yes.
Okay, perfect. Yeah, so honestly, it's pretty much the exact same as what we had in JavaScript. You make a list of n booleans, loop through the edges. Anything that shows up as the destination of an edge gets set to false. I had the booleans flipped from what we were doing. Like it starts at true and then gets set to false.
Okay.
And then
gotcha.
I went all fancy and used iterators. This is basically just the loop that pushes everything that was still true. It's just it uses iterators instead, in filter.
Gotcha.
Mm-hmm. Yeah.
Nice.
Yep.
What is
Also, I probably should have
the
comments.
so O.n is looping that number of times?
Yeah. This is an iterator it's an iterator that starts at 0, then goes to 1, then goes to 2, etc., all the way up to -1. Yeah.
What's the collect at the end?
So collect takes the iterator and then takes all of the items that come out of the iterator and puts it into like a list.
Okay.
If
So
if
that's
you
the
wanted
array.
yeah. Like I mean, you could do it pretty easily with like yeah. I think I can just do then results push I as I32, I think. Yeah, so you could do something like this and then return result, and this would work as well.
Do you have to specify the I32?
Yes. So the thing with Rust is that oh no. Frick. Go the other way around. So the thing with Rust is that Rust is like it's supposed to be like for system level stuff, and so
Yeah.
it tries to be super fast, but it doesn't want to be like C++, where it just kind of leaves a bunch of stuff up to the user to find. So the way that it solves it is by having like very in-depth, like a very in-depth type system and like very strict sort of rules on types and stuff like that. So it's very strict on the types and doesn't do very many automatic conversions. So like when you index into an array, you have to have it be a U size, but this one's an I32, so you have to like convert between them and stuff like that.
Gotcha.
Yeah.
That's interesting.
Yeah, it's to be completely honest, Rust is probably not very good for the contest because it's gonna take a decent bit longer than doing it in JavaScript, just because you have to like fix all of your like type errors and stuff like that.
Yeah, yeah.
But I don't know. I personally I like it because then it catches all the extra type errors I get when I'm first compiling are like runtime errors that I avoid later. So
Gotcha.
anyway, yeah, that's my solution.
Awesome.
Yeah, and this line again is basically just this, but shorter. Yeah, and it was in fact, let's see. I managed to I got it down here. So, it was like basically 90th percentile.
Nice.
Like that, yeah. Anyway.
Do you want to show yours, Omar?
I think it's the same idea, but using JavaScript. So my main idea is
I could see your screen, Omar. No, I can't. No.
No.
I was.
Yeah, okay, it looks like it was probably the same one.
No, I said I can see your screen. I'm saying normally the last few weeks we haven't been able to see it at all.
oh yeah.
I can finally see
now
it.
You see my screen now?
Yeah, finally.
Wow.
Oh yeah. This is the same thing.
Yeah.
I mean, the stuff we did in JavaScript was the exact same as that too.
My idea was just to figure out which points that no other point to it, which node has no other node point to it. So I initialize
Hold on one second. I can't. I'm just gonna mute someone real quick because they're kind of loud. Go ahead.
So first I initialize a map, like have for all node the value false. Then I loop through all the nodes, and if there is any node in the index 1, I map it to true. Then check all the map values and push any key if it is mapped to false. Let me console.log map really quickly to.
That's exactly what we did, except we use an array. What made you choose a map instead of an array?
Maybe using array is more efficient.
I honestly wouldn't be surprised if the compiler figures out that it's supposed to be an array and just does it under the hood.
But I use map because I want to map values into values. I think about mapping.
Why couldn't you do that with an array? Using the index as the number.
You could do it with array. So can I see your solution?
Oh, yeah.
I'm curious with how the speed compares with yours actually.
Yeah, what did you get when you submitted it, Omar?
It's a fast solution. Like
so like 50?
No. Because I put all the console log. Let me first.
Oh yeah, you gotta get rid of that.
All those console logs.
Oh, you know, oh man, my favorite thing is when you're doing something that's very, it's very heavy computation speaking, and then you put like a printout in a low level thing, and then like you lose like half your FPS because you have a printout.
Oh, actually, I'm a dummy. I actually kept the root nodes. Are you looking at my screen?
No.
Yeah.
Now I am.
In the set problem, I kept this.
Oh, yeah, I saw that. I didn't.
Oh, let me resubmit it without that. I wonder what it. Just like.
Maybe I should have said something actually.
Yeah, it's alright. The array was better.
Oh wait, really? Wait. That was last time. It was like 60%.
Well,
did getting rid of that one line? Oh, you submitted it a second time, and then it was.
Yeah, so it's about.
Oh really? Okay, so that's actually not that bad then. That's only like a couple percentage lower than than the array one was.
Yeah, we did two solutions, Omar. So we basically did the same exact thing you did, except instead of using a hash map, we did one with an array. Yeah, now look at the one with the array. This sucks.
What?
Well, they're
What?
just saying it. If you submit it again, though, then it always changes. That's the thing.
That's weird. Okay.
You
So
can
both.
get radically different input sets.
Yeah. So these are the
Oh,
solutions
really?
we did.
Oh, like so does it just auto-generate the test cases then?
No, I don't think they
so.
auto-generate, but they have a big set of them.
Oh, okay. I mean, for this problem, you probably could auto-generate the tests.
So
Well, there's a lot of caveats they have to meet.
What'd you say, Omar?
Why you sort the edges?
What do you mean?
At line 9.
Why do we have the result array?
No, at line 9 you sort the edges array. So
line 9 is a result array.
So we don't have to sort it.
I didn't sort it.
Oh no, he's looking at the Python.
Oh,
The
you're looking
Python
at
one.
someone else.
Yeah.
Oh.
Oh, you're looking at Lee's, I think.
I do wonder what is the fastest way to traverse a graph when it's done in the form of a list of edges. And this is actually an interesting problem.
I honestly like this one better. I feel like it's just like easier to understand.
Oh yeah, of course it is. Yeah, makes sense. And I mean, with modern compilers, it's not like it's that much slower.
No.
Yeah, and it's JavaScript, so it's all over the place. In C, it would definitely be slower.
Slower? In C?
Oh, the set one would be slower in C than the array one. That's what I mean.
Oh, gotcha.
Sorry, I'm rambling a little bit. In JavaScript, the difference between the two is probably not that much, because it's just such it's such a toss up, like how everything gets evaluated.
What do you mean?
Well, I mean, like it's a high level language, and there's so much variation in the different engines, and the compilers can probably check. Honestly, the compilers like V8 has been optimized like crazy, so like it's possible that it legitimately would figure out that, oh hey, I don't actually need to use a set. I can just use an array of booleans and just like it just compiles them both to the exact same thing under the hood.
Yeah, that makes sense.
Yeah.
Gotcha. Cool. Does anyone else have something they wanted to share?
I mean, I solved it. I'm not going to show you guys because it's super ugly and super slow, but it's the first time I've ever solved a graph, so I'm giving myself a pat on the back. But I'm going to look
Hey, go ahead and show that.
Yeah, I want to see it.
Yeah.
Come on.
Hey man, you gotta remember engineering. You like when you well, first of all, you never make a perfect solution. Second of all, your first solution's always trash.
And the real benefit in explaining your solution is not to like show off some fancy solution. It's to learn how to articulate these technical concepts. That's something that I know developers with tons of experience who can't do that because they don't practice doing it, you know?
Oh yeah. Well, just look at all like the physics professors at college that are great researchers, terrible profs, terrible lecturers.
You know what I'm saying?
Yeah. But I mean, I can tell you right now. I mean, you can even just learn the content, not even just how to explain it. Just learn the content by explaining it.
Yeah.
I don't know how to share my screen, but I'll share it. I'll share it.
Oh, you got it?
A button that says, I see a button that says share your screen. I'm pushing it. Nothing's happening.
Yeah, it says screen, and then something will pop up in the middle. It'll say screen share. It'll allow you to choose a specific application or your screen. Just choose screen and then screen 1 and go live.
Wait.
Here, hold on 1 second. I'm gonna show you on my screen.
Share screen.
Watch my screen real quick. Tell me when you see it.
Okay. Hold on. Oh, I'm not even. Oh, I'm all over the place right now.
All good.
Okay, I am watching your screen now.
All right, so you see this little button right here?
Yeah, I see it.
when you click that button, there's gonna be, this is gonna pop up, and you're gonna be able to choose between a specific application or screens. I always choose screens because then I don't have to like toggle back and forth between different screens. And then I just go live, and that should share.
Yeah, if you pick
Okay.
application, then you can be looking at one thing and everybody else sees another, and it gets awkward.
Yeah.
But then you don't accidentally share something else. You don't want to.
Mm-hmm.
I'm gonna try to do it. So I found button. The button says screen.
Sure.
I'm gonna open my system preferences to allow Google Chrome to see my screen. Like, I'm sorry, I'm a weirdo about all that stuff.
Oh, you're in browser.
Yeah, I'm in browser. Okay,
Ah.
I can't change these settings without quitting. I'll take a screenshot and try to throw it in the chat. Maybe that'll work.
All right.
You can also just copy paste the code too. Do you know how to do Do you know how to do a code quotation in the chat?
Oh, do I know how to do that, bro?
Yeah.
I barely
Also,
know
which
how to
chat are you pasting it into?
I barely know how to unmute myself.
Oh, okay.
Like,
which chat are you going into?
I'll tell you what. I'll probably try to put it in the lobby chat, our chat. Does that work?
No.
I'll put it in the same chat Omar put his solution in.
Oh, yeah, if you do, oh goodness, this is going to be atrocious.
I'll do atrocious
Goodness.
things.
I'm trying to, so if you know like the backtick?
Yeah.
Oh goodness, okay, this is actually kind of annoying to type in here. Basically, if you, oh wait. Yeah, okay, so if you put like 3 backticks, so the backtick is on the key that's like above your tab key. If you put 3 backticks and then click enter, you can paste in your code, and then click enter again, put in 3 backticks, and then
In the chat,
it'll be
then
it will
formatted.
like actually format your code too.
Look not like crazy. Okay, I'll try that.
Yeah, like it'll like look like that. You gotta use
nice.
You gotta use the
Otherwise, it looks like this.
you
Oh
gotta use
yeah.
these characters.
You don't even have to
3
put them at the
backticks.
end. Yeah, 3
Oh,
backticks.
you don't?
Then
You can actually get
pasted.
syntax highlighting too if you put if after the 3 backticks you put the name of the language. So like
there you go. It's in there.
So I can do my solution here. And it's all syntax highlighted.
You have color. Oh my god.
Yeah. It's actually so I think whoever designed this had some like development background because this is all the same stuff that you would use in Markdown, like if you were making a README on GitHub.
Oh, nice.
Yeah. Like they actually include like a lot of stuff. Like you can no joke, like they have like syntax highlighting here for like every
Wait, how'd you do this highlighting?
So after the 3 backticks,
yeah,
you put the name of the language on the same line. Oh, that's okay. Okay. So you do.
Oh my god!
Like,
after the second
if you want to
3
do
backticks
Python,
or the first 3?
you would do like this, like that.
Oh my god! This is wild.
How do I press enter now? It's not letting me press enter.
Oh yeah. Well, you have to end it with the 3 backticks, and then it'll let you press enter.
Oh, gotcha.
Mm-hmm.
Oh, this is so cool.
Wow.
Yeah, it really is. I know, right?
Omar, I hope you're paying attention, Omar.
Yeah.
This is awesome. Wow. Okay, cool. Nice.
So we need a track for live share on Leetcode. Like, we need a track for live share on Leetcode if we want to as a group program on Leetcode.
Share the code editor? Yeah.
All right, let's see what we got here. Okay, so you use 2 sets, a first and a second.
Yeah. It's ugly.
Oh,
so I took the first.
Okay.
I think I go through. I think the solution. This solution was among the faster than 5.34%. It took over 6,000 milliseconds. But to make 2 sets, I take the first element, Put them all in the set I call first. Pick the second element. Put them all in the set I called second. That's what the for loop does. I turn them both into an array. Filter the first elements. I'm filtering out anything that appears in the second array. So any, and then returning the filtered.
Yeah,
Yeah,
I like that.
that's basically what we did, except you only selected things that were included as a first element in the edge. Like, that's basically the same. Yeah.
I did it a lot slower because I didn't think of a hash map or anything cool, but it worked.
No, you didn't need a hash map. All you needed was a set array, right?
Yep.
Actually, technically, a set is usually implemented using a hash map anyway. It's like it uses the same stuff.
Yeah.
But yeah, you actually don't need the first array thing. Like you don't need to keep track of which one's the first. You only need to keep track of what's the second. Yeah. Just include basically you return every number between 0 and n that isn't in the second set.
But yeah, I didn't even think to use n.
Yeah. Yeah, but I mean this yeah. Unless you have like nodes that aren't connected to anything, this works too.
Yeah.